Predictive text algorithms are a class of algorithms used to autocomplete words and sentences. Google's Smart Compose feature within Gmail is an example of one of these algorithms. Introduced in 2018, Smart Compose was advertised as a feature to which would reduce the time spent writing emails and increase user efficiency. Smart Compose makes its suggestions based on the prefix of a word sequence and email context. Suggestions based on prefixes had already been done in Google's Smart Reply technology, so the main challenge was the context dependency. This was accomplished by encoding the subject and previous email by averaging the word embeddings in each field. Then joining those averaged embeddings and feeding them to the target sequence. Predictive text reduces some of the complex cognitive tasks associated with producing a sentence, thereby reducing our cognitive abilities over time. This is an ethical issue because we are potentially compromising cognitive abilities for efficiency. An example of this is that as more and more young people have access to cell phones, it is plausible that predictive text also impacts vocabulary formation. This means that due to predictive text, young people who use such devices are going to have a very limited vocabulary. The stakeholders include those who regularly use digital written communication, in particular the younger generation who grew up with technology. They receive the benefit of reduced time and effort expenditure of using digital written communication, but also the negative impacts of reduced cognitive abilities over time. Companies such as Google benefit from users relying on their algorithm, which increases the company's revenue. Smart Compose is trained on billions of phrases and sentences. Language understanding models can reflect human cognitive biases, resulting in unwanted word associations and sentence completions. Therefore, this poses a potential bias within the algorithm itself. Since the algorithm is prefix and context-based, it poses a great risk of being biased based on the context. One year-long study found that secondary school children who used predictive text on their mobile phones made more spelling errors than non-users. Additionally, a study published in the Journal of Bioelectromagnetics says that children aged 11 to 14 abusing predictive texting in cell phones take tests more quickly and inaccurately than their non-texting counterparts. One way to potentially mitigate the negative impacts of the algorithm's outcomes is the addition of brain teasers or puzzles to work the same parts of the brain that are being used less frequently. Due to use of the algorithm,